This video is going to talk about sinusoidal graphs, the graphs of sine and cosine, which really have tons of applications out in the real world. Changing some of the parameters we're going to look at are things that are the difference between a very high tide and a low tide, the difference between the color of light that you see, or the pitch of the sound that you hear. So we're going to look at the details next, and then we can eventually see how they're applied. So here we have the sine curve. First thing you want to notice, it's cyclical in nature. And also, very important, it starts at the origin, it starts at 0, rises to a max of 1, down to a min of -1, and then it finishes one cycle back at 0. And there's some things we want to label on here. For example, we want to label the midline, which in this case is the x-axis. Right, that's the actual middle of the graph, but vertically. We want to label the distance from the midline to the max or min is called the amplitude. And how long it takes to repeat is called the period. And we use the letter T for period. So I can actually label it in a whole bunch of different places. I'll label it here. We often use time, so that along the x-axis, so that's why we use T for period. I can also label it, for example, right along here, along the x-axis, and that's where we typically see and marked off. So any distance where it starts repeating is the period. Finally, we have our max value and our min. We never go above the max nor below the min. Here we have the cosine curve. First thing you'll notice, it's almost identical to the sine curve. And we'll learn later that sine and cosine are simply just a shift from each other. So that the big difference between cosine and sine is the starting point. Whereas the sine will always start on the x-axis, cosine is always going to start at the max, or potentially it can start at the min value. In this case, the regular family of function, the parent function cosine, will start at the max of 1 and descend down to the minimum halfway through its cycle or period, and then when a period's completed, we'll be back at the maximum of 1. So here we look at the characteristics of the sine and cosine curves. And we have the parent of functions, the a, b, c, and d coefficients we can throw in there, and this will show every change that is possible. I'm not going to do these all at once to start off, but just to give you a preview of what they all do. So the first thing we want to notice is sometimes you do see a plus here, and a plus c, bx plus c. I'm going to stick with minus just because if we recall before, sort of inside the parentheses has the opposite effect. And when we talk about a and d are both outside, and so therefore they're going to affect vertical translations, or I shouldn't say translations, but vertical changes for both sine and cosine. B and c are sort of on the inside, and so they're going to affect the horizontal, they're going to affect the x values. So what do all these a, b, and c, d, what do they mean? Well, the first one is a, and a is the amplitude, or more specifically, the absolute value of a is the amplitude. It's how high and how low it goes above and below the midline. So then what's the midline? Well, d is the midline. So actually I should clarify, y equals d is the equation of the midline, where d is the vertical shift. The next ones are the horizontal ones, and they kind of work together in a lot of ways. And so the first one to talk about is the period, which doesn't actually show up here explicitly. But t is the period, one of the most important characteristics of the sine and cosine, and that's found by 2 pi over b if you're dealing in radians, or 360 degrees over b if you're dealing with degrees. B is the number of cycles completed per 2 pi or 361 revolution around a circle. Now the last thing we can look at is the horizontal shift, and that's found by c over b. It's whatever makes that parentheses equal to 0. And if you happen to have bx plus c, or this would be negative c over b, and would be the horizontal shift. So a thing we can note with the horizontal shift is our start point will always be found by solving the equation bx minus c equals 0. Our endpoint can be found by using the period and saying bx minus c equals 2 pi, again, if you're dealing in radians, or 360 degrees if you're dealing with degrees. And the last thing we want to point out and stress is that sine starts at the midline, or then y equals d. Cosine starts at the max or min.